Okay, about me. I'm a staff CloudOps engineer in Wrike. The main part is on my side is keep Kubernetes running all the time. So it's quite important one. Okay, I've got almost above 10 years experience in IT, 5+ with Kubernetes. Okay. Let's start about our topic. Okay, so we'll start with definition. What is multi-cloud solution? What is it? What is it, and why we need it? Okay. Then we talk about application layer, load balancer, and how we are using this multi-cloud connection. We're using Istio in Wrike. Okay. So let's start with multi-cloud solution. Okay, what is it and why we need it? Okay, so guys, what is it? Who using multi-cloud, multi-cluster solution? Right. Okay, almost everyone. Almost. Okay. So let's start from the definition. Okay, so multi-cluster Kubernetes is just more than one Kubernetes. Okay. But this part is quite important. Okay. So if you have, if your organization work with many Kubernetes cluster, quite important part is that you have tool to deliver your application to all Kubernetes in our environment. So that after that, you can say that, okay, I'm using multi-cloud solution. I just deploy everything in the same time, in the same way everywhere. Okay, so in this case, we can divide those solutions. So we can put those multi-cluster in the same physical hosts. We can use the same data center, or even we can use different clouds. So we have this hybrid cloud option that you can probably read everywhere in the internet. Okay, use hybrid cloud everywhere. Okay, so we know what is it. So the next question, why we need it? Okay, quite easy. Okay, for security reason. Okay, you have, okay, let's say 3 environments: dev, staging, production, and probably you don't want to share the traffic between them or share the resource between developers, development environment, staging, and production. Okay, just use three Kubernetes, separate them, and that's all. Okay, perfect. Okay, the second reason, ability and performance. Okay, imagine that you want to distribute your system. Let's say this hybrid something. So you have one Kubernetes cluster on premise, one in, I don't know, Google Cloud, Azure, whatever, and you can send traffic between them. And you have, okay, you don't have vendor locking. Okay, if one, let's say, cloud provider will be down, you still survive. Okay. Okay, this is okay. Or if, for example, you have need bigger performance, something like that. Okay, you have the spike of traffic. Okay, you can distribute traffic to the second cluster. Okay, failover. Okay, if something happened with one, you can switch to the second one, and you survive. Okay, why it's so important? Okay, you remember this one 2 years ago? Okay, now you know why. Okay. Yeah, who doesn't know that? Okay, do you need explanation? Okay, 2 years ago, one data center in Strasbourg, in one place, start fire, and everything burned. And people lost whole business because they didn't have disaster recovery. They didn't have in different place their business. So yeah, it wasn't pretty. Okay, and the third reason, low restriction. Okay, we know that geographic specification and regulation control. Okay, what does it mean? Sometimes you're not allowed to send your customers data to different locations. We are in United Europe, and we not allowed to send your client data somewhere else. Okay, you can ask why. Okay, what's the problem? Okay, the problem is that Facebook did that, and now he need to pay 1.2 billion of euro only from Ireland because transfer personal data to United States. Okay, they will fight for that, but okay, this is one of the problem. Okay, sometimes you don't want to send your client traffic somewhere, or you cannot. Okay, so we now what's the multi-cluster. We now know why we need to use it. Okay. So let's talk about application. Okay. I'm quite old, I think. I start my story with IT when everything was on one server, with one monolith application. So I remember the left side, okay, everything in one place, and then everything changed. Microservice, RISE, and everyone moved to a microservice. Okay, so let's imagine this situation. We have this monolith application. You have different function, different part in your application. Everything is one place. Okay, that's perfect. And you start using microservice. You just divide your monolith application to small pieces, or just write from the beginning. Okay, whatever, doesn't matter. And okay, let's see. Imagine that you have everything in one place, but we know that application not work like that. We have some function like login registry, some API to connect to backend, and so on and so on. So when you think about application in microservices, you will probably see something like that. Okay, so all connection from your client will connect to one point, let's say some API, and then to different part. So you can imagine that you have some tree of connection, and you can go deeper and deeper, create more microservice, and you end up like that. So this is the example of Uber, and they've got a lot of microservices. Okay, so we know that microservice create you can say that the tree of connection or something like that. Okay. So we see that, in your application, you will have different connection between microservices. So when you go back to your Kubernetes cluster, your microservice, you probably can imagine that you can have some kind of layer that the first layer or connection will go there, then you go to the second layer, and so on, deeper and deeper. Probably on the first second, you will don't connect, let's say, to your database. On the second, probably not. But on third, you want to connect to some place in your database or some other backend services. So just imagine that, let's keep that our application can be this layer of application, layer of microservice. Okay, so now you know that you don't want to have one cluster, one place. Okay, so you can just copy everything and that's fine. Just send traffic here and here and here, and that's fine. But the question is, do we always need to all services in all places? Do I always need to pay for all resources in all clusters? Let's say United States, and those are in EU. Probably no. So in case of multi-cluster, you can just divide that. Okay, let's say that one microservice, the first one will be here in one cluster separate, and he will connect to the other microservices in different clusters. Okay, so in that situation, you can save some resource in this cluster and use share service here. Okay, that's perfect. Okay, and what kind of application layer we have in Wrike? Okay, we go very similar way about thinking about our application. So Wrike is distributed system which divide customer in segments in data server. You can imagine that, we just divide customer that, they are living different part of the world, Zosia mentioned that we are a global company now, so we have some customers in United States, some customer in EU, and so on. So probably we don't want to send those data to United States or something like that. And probably it will be better to have the data center closer to clients. So we divide those customers. We divide Kubernetes cluster, and this distribution system gives us some features. First of all, we don't have one single point of failure. Okay, if something happened, okay, in worst case, only some part of customer will not use all feature from our application. Okay, and we can just distribute our customers, what I mentioned. Okay. What is this advantage of this distribution? Okay. Probably we cannot have 100% for every customers. But I mentioned that, okay, if something's happened in one place, it will work for this, I don't know, 99% or something like that customers. And we will have some cross accounts data. Let's say it will be used for everyone. Okay. Okay. So we have those, let's say, layers. The bigger one is global layer. It's not connected with our distributed system, you can say. It's connected with all accounts in all data centers. So we are connecting to everywhere. The second one is region layer. So we can imagine the region layer will be connected with one place where we have on the world our DC and so on. So in this layer, we'll connect to all accounts in this place. And then we have the segment layer, the lower layer of our application, which connects to the part of users. And then we can just, okay, I've got the right picture here. Okay, everything's smooth. The global layer, okay, it's above of everything. Then we go deeper. So we can say that, okay, let's say this global layer can be login registry. So when you go to Wrike and just log in, you are going to this layer. When you're just putting some task, you are going through regional layer to segment layer, and you get some data from your account, from your place in the world one. Okay, so we have this layer. Okay. And the most important part, load balancer, the way. The question, okay, you have divide your customer, you have your multi-cluster, and how you send your traffic there. How to send traffic from, let's say, Prague to my account, which will be in, I don't know, let's say, imagine in Warsaw or somewhere else. Or I came to vacation to Europe, and my company is United States. How to do it? Okay, there is a plenty option. The first, probably you know that, AWS Route 53. Okay, you can buy and use CDN. Okay, you can use API gateway like Congo, Flow, and everything on the market. Okay, you can build your own. It depends probably from some historical background from your company. Probably if you start, probably you want to use something new. If you have some background and you have some knowledge how your application is working, probably just on-premise. And we are the one who are using on-premise solutions. Okay, but let's talk about incoming traffic. Okay, if you have one cluster, it's easy. Yeah, it sends everything to one place. Let's say you are using ingress controller. I've got here API gateway is the same in this case. Incoming traffic, okay, check what's going on, and then send to the correct service. Quite easy. Okay. If you have multi-cluster solution, it's not so easy. Okay, so you have this simple ingress in front of all cluster, and somehow you need to know how to send the traffic. Okay, let's say you have this application service here. How you know how you route your traffic from customer to this service. Okay, this is not so easy. So there is, let's say, API gateway or magic. Okay, let's call it API gateway here. So incoming traffic goes to API gateway, and API gateway will know, or load balancer will know where to send this traffic through service. Okay, so how we did it? How we create this load balancer, this API gateway? Okay, so we have normal load balancer on the network level. Then we are using normal VMs, and on top of VMs we have Nginx and Azure Proxy. And Nginx is used for LS termination, IP detection, some rewrite, setting some headers like x404, setting collect access log, selecting the edge proxy upstream, and hide some internal headers for know where to connect and so on and so on. In case of edge proxy, in our case, it's part which is responsible for connection to the Kubernetes cluster. In this case, we're just checking some header. One of them is header which is saying to which route you should be sent. Okay. If you have that, okay, go to this ingress controller. If you don't, go to different and check what should be and just redirect. Okay, quite simple. Okay. So we've got this load balancer. And what about the service? Okay, we talked about this layer. We have this load balancer here and all connections. So you can connect to the load balancer, and based on the header, we just connect to the correct ingress in correct Kubernetes cluster. And then in Kubernetes cluster, we are using Istio ingress gateway for that. And based on the connection, what we have in header, decide where to go, to the region, to the segment layer, and then customer gets his data. Okay. So what about multi-cluster connection? Okay, we are using Istio, so some information about Istio. Istio is service mesh for connection between services, and it's quite advanced, you can say. So instead of using one configuration file, we are using control plane with all information about where to send, what kind of logic we want. So in case of when you have Istio, you have some extra feature like sidecar proxy, so everything will go to sidecar proxy. Okay, what kind of feature we have from Istio? Okay, so all traffic proxy are moved from ingress controller to dedicated sidecar container. Each pod has sidecar container that intercept network input output, so we can control what's going where. Okay, all configuration about traffic is saved in custom resource based on custom resource definition from Istio, so we can define exactly what you want to do, where to send, what kind of feature you want to use. Okay. All data instead of keeping in Kubernetes API are kept in control plane. So control plane is sending and updating all proxies sidecars using service and endpoint and custom resource. Okay, and the most important part in our this part. Okay. Okay, so data pipe is responsible for updating all proxies all the time online, so we don't have any distortion in working. And the most important part, okay, because of that, because of using Avon and Voy, we can use performance traffic routing in our way how we sending the traffic. Okay, so basic view of Istio, probably you know that. Okay, control plane, keep everything, service, sidecar, and it's control traffic. There is also Istio ingress controller. Instead of normal ingress, we can use from Istio. And then we have almost also the same advanced routing. So we can keep traffic on incoming traffic. Okay. And now I have big picture. Okay. So we go through it. Normal path, user, API client, firewall. We know that, load balancer, our VMs. And then we have one or more, two or more cluster. And on each cluster, we have those application layer. We have this ingress, Istio ingress gateway with all features about how to send the traffic, what to do with traffic with correct headers and so on. But we have also part responsible for multi-cluster communication. So in this case, if you connect, somehow your connection go to this cluster and you don't have this service here, it will be redirected to this one. And if something is going wrong, it will be redirected to a different one. So you even can set some configuration. If something happens, go there and so on. So this is the basic what we are using. So based on ingress controller, Istio ingress gateway, we control and route the traffic between the between our multi-cluster solution. So yeah, we are using this one for that. Okay. Okay, and that's why we can use this distributed system, because we have different client on different Kubernetes cluster, and we can just route the traffic between the cluster using ingress control. Ingress, Istio ingress gateway, all these features. Okay. Questions? Do you have any? Yeah, sure. I don't know if you need a microphone.
Yeah.
Thanks. So my question, how do you connect different clusters via network? Is it virtual network, or do you have a static IP address?
It's our cluster is connected, so we have traffic, we have routing between them. So it's we have routing between the networks, so it's not it's not by IP static connection, but we have routing between the network private networks. I don't know if I answer your question here. Okay.
Hi, thanks for the presentation. My name is Pavel. Just wondering, when we're talking about the traffic routing, is it only about the incoming one, or the traffic between the services as well?
Oh, it's a good question. Okay, so in this case, we are talking about incoming. So if you incoming traffic goes to the wrong cluster, it will be redirected. So in this case, if you want from one service connect to the second cluster, you need to go to load balancer. But this is a good question. I don't know if we have time. Okay, and it wasn't okay. Prepare question, but okay, it's the question about the connection between services is not so easy. Okay, because when you have connection between services, you are probably using DNS in Kubernetes. And it's not so easy to connect from one service. Imagine that, okay, the network is not the problem. Okay, you have connection between the services, but the question is how you populate the DNS from the second cluster to the first one. And okay, it wasn't prepared, but I have the slide for that. Wonderful. So a few slides, but because it's quite important. Okay, so in case of DNS, in Kubernetes, you know that we have core DNS or kube DNS, depend of version of Kubernetes you're using. So every time you just create a service, it will create the DNS. And the lookup will be looking like that. Okay, so name your application, your service, namespace, SVC, cluster, local, SVC, and so on and so on. So the questions. If I want to connect from one service to the second service in different cluster, how to do it? How to populate this information to the second one? Okay, you can try it with Istio. Okay, it's possible because you have sidecar and just see all traffic. But you need to do it one by one. And the question is how to synchronize in every cluster the same. So there is options called Admiral. This is external application will synchronize service in your multi-cluster solution. There is also Kubernetes multi-cluster service. It's part of Kubernetes enhancement proposal. You can also find this in Istio documentation. But still you need to use Istio for that. But there is the option. Okay, this slide for Admiral is connected to every cluster and synchronized. Okay, but there is the option. It's using eBPF and okay, it's called Cilium. So in that case, you don't need any sidecar. And because you are using eBPF on the bottom of the network in your Kubernetes cluster or even between your multi-cluster, so eBPF tooling scripts know where you are connecting. There is the new feature. It's quite fresh. If you want to have global service in all cluster, you can use something like that. Service Cilium IO global in your annotation in your service, and it will be propagated everywhere. So every time you can just connect to one service, you can connect to different cluster. But there's the option, it's quite new. In that case, you can use and connect to different cluster, different service in different cluster. Yeah, okay.
Thank you.
Yeah.
Do we have any other questions? Yep.
Hello. My question is very general, actually. I would like to ask you, like, why Istio? There are other solutions in the market, so why did you choose specifically Istio? And what do you think about it? Is the best solution for your needs?
I think it was best when we started. It's not so easy because it's not true anymore because probably I saw someone was on KubeCon this year. The guys from Cilium told that they introduced service mesh on Cilium, so you don't need to use some external one. You can have everything from the Cilium. So maybe this is the case. Instead of using all option about service mesh, you can use Cilium and have everything in one place. Okay, I think worth to test.
One question. So how I'm understood, you install on a virtual machine all what you need for container for your Kubernetes, but why you don't use maybe like I take it Azure, yeah, Kubernetes container registry or another things like another microservices for this.
You mean why we didn't use
When you install a container or something like that? Because many people like don't use virtual machine or on-prem when you have some like container.
Oh, you mean why we don't use solution like Google Kubernetes cluster and so on and something like that?
Yeah, some
we are using.
Okay.
So I was talking about load balancer, that we are this part of how we send the traffic in front of Kubernetes. We are using on virtual machines, but the Kubernetes cluster we are on premise and on cloud, so it's not like that.
Okay, but you install the container in your virtual machine, or you install it in a like container registry or something like this.
I don't know if I understand you correct. Okay. You are asking where we have Kubernetes.
Like container, where's the container?
Where is the registry of containers? It depends of our environment, but okay, we use the public one from the cloud.
Okay, thanks.
Registry. Yeah. Okay.
Sorry.
Just a general question. So what's the split between your on-prem and cloud infrastructure? And what's the purpose of you keeping your on-prem infrastructure so far? Is it more for legacy historical reasons or?
Okay, some clients want that we have have infrastructure on the cloud from some reason. That's why some traffic is going on the cloud. Why we are using on premise? I think we are. I think maybe it's okay. I'm looking for the word. Okay, I think we start from that. So sometimes it's hard to just left everything and start going to the cloud. From the price or resource, it's okay. It's probably cheaper to keep everything you have already. But from scalability, is better going to cloud. So I think 1/3 something like that is in cloud. 2/3 is on premise. It depends on location, so on and so on. Probably in the future, if we go to different location, it will be easier to use a cloud solution because we don't need to spend so time for preparing everything. But okay, that kind of solution is that kind of decision is also based on historical reason why how we started. So, yeah. But probably this ratio will be changed in the future. So, okay.
I just want to ask related to the security part. The first option why you create you have this multi-cluster solution. I see you have tenant isolation. I'm just thinking, is there any fail-safe? Because I see the communication is coming from the gateway down to the clusters, right? Is there any fail-safe? Because I see there's a separation between the Kubernetes, but the gateway itself, if something happens, it means there is access to all the gateways.
Okay,
so
okay. On this slide, okay, it was like that. But in future, in real life, you have different load balancer in front of your environment.
so in front of each gateway.
Yeah. So you